A very good morning, friends. I am Mr. Chillian, Faculty of Geography, Sri Ram's IAS Academy. So today, my dear friends, we'll be discussing about one very important topic called as earthquake. See here, when I talk about earthquake, often it will be there in news. Because somewhere, if you ask me, in one calendar year, how many feelable earthquakes will be recording or somewhere will be having? The data sheet says that somewhere the number of feelable earthquake is in the sense under an ideal condition, anyone can feel it. Not necessarily only the sensitive seismograms will feel it. Somewhere, million plus earthquakes are recorded every year, feelable earthquakes. So, on an average, somewhere every 30 seconds, you'll be having an earthquake, and that's the reason always I understand earthquake is very, very common. And of course, once in a while, we'll also have large earthquakes, devastating earthquakes. Very recently, also, we had this twin earthquake striking Turkey and Syria. And of course, repeatedly, within span of, say, for example, 2 to 3 weeks, two devastating earthquakes have struck Turkey. And of course, when I talk about India, Himalayan regions are highly prone to earthquake. And of course, very recently, you would have heard about a news regarding NISAR satellite, a joint venture between ISRO and NASA. And one of the mission, say for example, NISAR has plenty of missions, and one of the mission is to study about the seismic zones or those regions of Himalayas which is highly prone to earthquake as such. So, my dear friends, earthquake often it will be there in news. It was there in news. It will be there in news in the near future also. Now, regarding the syllabus part of geography, earthquake is very important both for your prelims and mains. The topic earthquake is explicitly mentioned in your mains examination. So, my dear friends, having said this, we'll try to understand what exactly is an earthquake, why we have an earthquake, what is a causative factor, and of course, we'll also talk about some of the terminologies that is associated with an earthquake. What are the different scales that is used to measure the earthquake, etc. We'll be discussing about. Right, my dear friends. Now, the name itself says earthquake. Quack means what? Shaking. If somebody is asking you what exactly is an earthquake, you can simply tell them quacking of earth is called as earthquake. Nothing wrong. Only thing is that I have to refine my sentence. Quacking of earth is called as earthquake. Nothing wrong about it. But when I talk about quacking, quacking is all about what? Shaking. The shaking of earth's surface, you call them as what? Earthquake. Then comes the question, why? Why exactly this earth surface has to shake, if you ask me? It is all because of sudden release of energy. From somewhere, all of a sudden, if the energy is released suddenly, this energy will be propagating or traveling via the different rock layers of the earth. So, whenever it is traveling in the surface of the earth, this propagation of this wave or this wave travel will somewhere it will be inducing that shaking amplitude. That shaking amplitude that is resulted due to these waves, you call them as what? Earthquake. So, my dear friends, what exactly is an earthquake? The sudden release of energy from a deformed rock which induces the shaking of Earth's surface. You call them as what? Earthquake. Right, my dear friends. Having said this, now comes the question where exactly this energy is released, if you ask me. That place from where this energy is released suddenly. The word sudden is very important. Okay. The sudden release of energy, where exactly it is released, if you ask me. That particular point, you call them as what? Focus. Or you call them as what? Hypocenter. And my dear friends, the point which is located on the surface of the earth and above the focus, exactly above the focus and on the surface of the earth, we call them as what? Epicenter. Epicenter is the nearest point on the surface of the earth with respect to what? Focus. Any earthquake, my dear friends, where exactly this earthquake will be recorded first on the surface, if you ask me, it will be recorded in what? In the epicenter. And of course, epicenter is the place where exactly I'll be having the maximum impact of any earthquake as such. Right. So, what is focus or hypocenter? We have an idea. What is epicenter? We have an idea. And of course, the distance between the focus and epicenter, we call them as what? Depth of earthquake, or simply you call them as what? Depth of focus. Right. So, these are some of the technical terms that is associated with this earthquake. So, what do you mean by focus? Focus always lies below the surface. Always. Otherwise, you also call them as what? Hypocenter. Now comes the question. Okay, fine. I understood what exactly is an earthquake. Why exactly I'm having an earthquake? Very simple, my dear friend. See, and more than everything, first and foremost, if you ask me where exactly I'll be having this earthquake, location, if you ask me, normally I would say earthquake is confined to plate boundary. Largely it is confined to plate boundary, my dear friends. Right? But if you ask me, do you mean to say that we'll not have any earthquake outside the plate boundary? Absolutely not. Am I right? It means, let me tell you one thing. There is no place on earth which is completely free from earthquake. What will change from place to place is the probability of having an earthquake, intensity of this earthquake, frequency of this earthquake. Right? Of course, I can also use this word called as magnitude. That's what will be changing from place to place. But let me tell you, there is no place on earth which is completely free from what? Earthquake. But still, when I talk about large sized earthquake, obviously, yes, they are confined to plate boundaries. Plate boundaries are highly susceptible, vulnerable to earthquakes. Frequency is more. Of course, the probability of having an earthquake is very high. And the size of this earthquake will also be what? Very, very large. So, somewhere now, as of now, I'll confine to plate boundaries. So, what is a plate boundary if you ask me? See, I know the fact that entire lithosphere, my dear friends, entire lithosphere, the outermost layer of this earth is divided into number of fragments and pieces. That fragmented parts of this lithosphere, we call them as what? Plate. We call them as what? Plate. Okay. Somewhere we have n number of plates. Of course, the entire lithosphere is divided into 7 major plates and nearly 20 minor plates and n number of micro plates. Forget about the name of the plate. And all these plates, my dear friends, they actually go for a movement because lithosphere is floating over asthenosphere. Asthenosphere is a layer of magma. And there is a movement of magma within asthenosphere. So, given the case, what happens is lithosphere floats over asthenosphere and goes for a drift. And this is what we call them as what? Plate tectonic or plate movement, my dear friends. So, one thing I understand, the land where I stand is not static. They are having their own movement. You call them as what? Plate movement or plate tectonic. Okay. And my dear friends, because these plates are moving, two or more plates will be interacting with each other along the boundaries or the margins of this plate. Is what we call them as what? Plate boundaries. And my dear friends, what can be the different types of interaction if you ask me? There is a possibility that two plates can move towards each other, and that boundary we call them as what? Convergent boundary. There is a possibility that two plates can move away from each other. You call them as what? Divergent boundary. And there is a possibility that two plates can slide past each other. You call them as what? Transform boundary. So somewhere I understand what exactly is a plate boundary. So plate boundary is the place where two or more plates will be interacting with each other. What are the three different kind of interaction they have is convergent, divergent, and transform boundaries what they make. And my dear friends, along every type of plate boundary, some kind of stress is induced. Only the type of stress will be different. Type of stress will be different, but some kind of stress is always there. For example, along the convergent boundary, I'll be having compressional stress. Along the divergent boundary, I'll be having normal tensile stress or tensional stress. Along the transform boundary, what I'll be having is a shearing stress. Stress is universal. Okay. Now I'll try to understand what exactly is an earthquake. Say, for example, I'll put it this way, my dear friends. First, I'll just talk about a balloon experiment, a simple balloon experiment, what I can understand. You take a balloon, you blow this balloon. Somewhere I'm trying to inflate this balloon. So every time I induce some stress inside this balloon. When I blow this balloon, when I inflate this balloon, what I understand, I'm inducing some stress in this balloon. Every time I blow it, it becomes bigger, 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 and bigger. But I should understand, whatever the stress I'm inducing there, it is actually getting stored inside the balloon in form of some energy. So slowly, steadily, the energy is also getting accumulated. The balloon is becoming bigger and bigger at one point of time. Say, for example, the balloon is reaching a threshold limit. What is a threshold limit? The maximum capacity what this balloon can withstand. You call them as a threshold limit. After this balloon reaching a threshold limit, if you blow the balloon further, if you induce further stress, what happens is balloon will burst open. If the balloon is bursting open, my dear friends, what I understand, not that last stress what I'm inducing alone is getting somewhere released. All that energy which is accumulated since the beginning is getting released suddenly at once. Right? Now, what I have to do? I have to replace this balloon with a rock. Take a rock. Assume that I have a ductile rock. You're inducing some stress in this rock. Whatever can be the kind of a stress it can be. It can be a compressional stress, it can be a normal tensile stress, or it can be a shearing stress, whatever is the case. Whenever the stress is inside or whenever the stress is induced in a rock strata, the stress is actually getting accumulated in the form of what? Energy. And slowly, steadily, the energy gets accumulated. Right? At one point of time, my dear friends, assume like balloon, the rock is also becoming what? Somewhere it is reaching a threshold limit. Rock says, no, I cannot sustain further stress. The plates are still moving. And if there is an inducement of stress, this rock will break open. And when the rock breaks open, all that accumulated energy will get released suddenly and at once. That is what you call them as what? Earthquake. So what is an earthquake? Earthquake is all about a sudden release of energy. For the energy to get released suddenly, there should be an accumulation of energy. What is causing this accumulation of this energy is all about inducement of stress. And what exactly is causing this inducement of stress, if you ask me, it is all about plate tectonic or plate movement, my dear friends. Right? See, tomorrow, if all the plate movement stops, if asthenosphere becomes solidified, if I do not have any more plate tectonic, I'll not have earthquake. I'll not have volcanic activity. I'll not have mountain building process. Right? No endogenic forces will be there. So, what is the ultimate reason for having an earthquake, if you ask me? The ultimate reason for having an earthquake is all about what? Plate movement as such. And that's the reason, my dear friends, earthquakes are very, 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 very common along what? Plate boundaries. So, what is an earthquake? I know. Why exactly we have an earthquake? That also we know. Now, my dear friends, some of the technical terms also I said. What exactly is the focus? I said. What is epicenter? I said. And I also said what exactly is depth. And let me understand, my dear friends, somewhere the general idea says that depth of focus is inversely proportionate to intensity. As of now, if you ask me what exactly is intensity, I would say intensity is all about the impact of an earthquake. Right? What exactly is the loss that can be resulted by an earthquake? You call them as what? Intensity. See, what can be the loss? Loss can be loss of life or it can be loss of property. Right? And that's what I call them as what? Intensity. Maybe I'll put it this way, right? Damage caused by an earthquake, you call them as what? Intensity. So what exactly it says, if the depth of focus is more, intensity will be less. That's what the idea is. In that way, my dear friends, if you ask me, okay, what is the deepest earthquake that we have recorded so far? Deepest earthquake. This deepest earthquake or the deepest focus, I'll call it as. The deepest focus, what we have recorded is somewhere approximately around 700 kilometers of depth. 700 kilometers of depth is not even in lithosphere, it is there in mesosphere. Of course, I understand hardly that will be having an impact on the surface of the earth. But if the focus is very near to the surface of the earth, the intensity impact of the earthquake will be very, very high. Okay. Right, my dear friends. Now, what exactly is an earthquake? Some of the technical terms regarding this earthquake we have taken it. Now, somewhere what you are seeing here is map of India, the seismic zones map of India. Somewhere NDMA, National Disaster Management Authority, has somewhere divided, classified the different regions of India into different seismic zones, right? Different seismic zones. Somewhere it has divided them into 4 seismic zones, my dear friends. Zone 2, Zone 3, Zone 4, and Zone 5. Just there is nothing called a Zone 1 when it comes to classification of seismic zones in India. There is no Zone 1 classification. See, this has to be noted because this comes as an exception. Okay. There is no Zone 1 classification in India. Okay. See, some of your atlas, they have given us 5 zones. Somewhere you would have come across something like very high damage risk zone, high damage risk zone, moderate damage risk zone, low damage risk zone. Some of your atlas also has something called as very low damage risk zone. This very low damage risk zone also can be considered as zone 2. Okay, fine. Now here, what I'll do, I will talk only about zone 5 in India. What is zone 5 in India? See, the name itself says very high damage risk zone. The probability of having an earthquake is very high. Not only that, The frequency will be high, intensity will be high, magnitude will be high. That's the reason we say these regions are highly prone to earthquake. There are 7 regions in India which is marked under zone 5. What are they? Run of Kutch, Kutch Peninsula, Gujarat. Very recently we have included 2001 January 26th we had one devastating earthquake there in Bhuj. So after Bhuj earthquake we have included that. Then Kashmir Valley, my dear friends, in and around Srinagar. Then Himachal Pradesh, the eastern Uttarakhand, the Kumaon ranges of Uttarakhand, the northern Bihar, northeastern state except Sikkim, and Andaman and Nicobar Islands. These are the regions where exactly we have this zone 5 in India. Now, my dear friends, if you ask me, okay, all this zone 5, if I just take it, and somewhere if I am just looking for one commonality, if you ask me, what is common? All this zone 5, my dear friends, except this Bhuj, right? Run of Kutch, Bhuj alone, I'll just leave it now as an exception. Rest of this region, if you just take it, Kashmir Valley, Himachal Pradesh, eastern Uttarakhand, northern Bihar, northeastern state, right? Andaman and Nicobar Islands, all these, if I just take it, what I understand, my dear friends, these are the places I have the presence and extension of what? Himalayas. Himalayas itself is a young fold mountain. It's an young fold mountain. And my dear friends, you may wonder, what is this? Do you want to say that Andaman and Nicobar Island is an extension of Himalayas? Obviously, yes. Andaman and Nicobar Island is the direct extension of Arakan Yoma Mountains and indirect extension of Himalayas. Andaman and Nicobar Island itself is an example of young fold mountain, right? And my dear friends, let me tell you, all these places, what we have marked it, they are located along the active tectonic plate boundary. See, the entire Himalayas, the Arakan Yoma Mountains, and the Andaman and Nicobar Islands, they are located along what? The active tectonic plate boundaries. So I know the fact that any plate boundary is susceptible to earthquake. They are prone to earthquake, right? They are vulnerable to earthquake as such, and I do not have any, say for example, right? Normally, right, it is understandable that plate tectonic or the plate boundaries are susceptible to what? Earthquake. That I can understand. Zone 5. If I have a devastating earthquake in zone 5, I can understand because that is earthquake prone zones. And my dear friends, let me tell you, even Delhi is one of the regions which is highly prone to earthquake. It is high risk zone, my dear friends. High risk zone because it is seen as the extension of zone 5. Delhi falls under zone 4. See, some of the very important locations, when I talk about the considerable locations of Uttar Pradesh, Bihar, West Bengal, Delhi, Haryana, Punjab, all these are actually located under what? Zone 4. Zone 4 is also prone to earthquake, but not to the degree of what? Zone 5 as such. Okay, fine. Having an earthquake in zone 5 is very common because they are active tectonic plate boundaries. Now, having said this, my dear friend, somewhere if I'm just focusing on the eastern Maharashtra, right? Somewhere if I just focus on this eastern Maharashtra, particularly when I talk about Eastern Maharashtra comes under zone 2. Zone 2 means what? Low risk zone. To be very precise, some of your atlas will be showing as zone 1. There is no zone 1. But there is a classification called as what? Very low damage risk zone. Okay. Now see, NDMA's classification is saying that this region, Eastern Maharashtra, comes under zone 2, right? Which is generally considered as low damage risk zone. What is the meaning? Probability of having an earthquake will be less. Even if I have an earthquake, the size of the earthquake will be very less. But unfortunately, in 1993, my dear friends, we had one devastating earthquake in Maharashtra, epicenter called as what? Latur, my dear friends. We call them as what? Latur earthquake. What is interesting here and a kind of eye-opener here, this Latur earthquake, my dear friends, it is actually located in very low damage risk zone. What you call them as what? Zone 2. This region is considered as one of the regions in India which is comparatively, relatively free from earthquake. But what we had is a devastating earthquake. Nearly, my dear friends, nearly 10,000 lives we have lost. 10,000 lives. And see, comes the question, right? How come it is possible? What exactly has led to this devastation, if you ask me? Is it a natural earthquake, if you ask me? No. This earthquake, Latur earthquake, is not a natural earthquake, my dear friends. Latur earthquake was regarded as a man-made earthquake. So just want to put a point that earthquakes, not necessarily when I talk about the inducement of stress, The inducement of stress need not necessarily be created only by the plate movement or plate tectonic. Sometimes even human activities can result in what? Causing that earthquake. Right? If human activity can induce a large scale stress in the Earth's surface of the Earth, right? And that can also eventually result in creating an earthquake. Such earthquakes, we call them as what? Man-made earthquakes. My dear friends, nowadays human beings are equally competing with the nature and tells that, okay, I can also create an earthquake and we are creating it. We call them as what? Man-made earthquakes, right? And my dear friends, when I talk about man-made earthquakes, I'm also bringing you a kind of a comparison where I just want to show you this Latur. Somewhere you can find Latur earthquake here. Latur earthquakes actually happened in what? This zone 2. Okay. Now, if you ask me what exactly is the reason for Latur earthquake, it is human activity. What human activity, if you ask me, right? There is a dam induced earthquake, my dear friends. In that way, whenever human activities can somewhere change the stress and strain pattern of this earth, that activity can also result in what? Earthquakes, right? In that way, if you ask me, which human activity has caused a large number of earthquakes? If you ask me, it is mining as an activity. Whereas, which human activity has created large earthquakes? If you ask me, big sized earthquakes, if you ask me, construction of dam. Latur earthquake is a classical example. 1967, we had a Koina Nagar earthquake. Again, that is a classical example of dam induced earthquake. Sichuan earthquake of 2008, that is again an example in China where there is a dam construction or induced earthquake we had. So dam, artificial lakes, reservoirs, etc., my dear friends, they are highly susceptible for, or I put this right, they have caused an earthquake, and some of the earthquakes which is resulted by these dams and others, the devastation resulted is also what? Very, very high. And apart from that, over extraction of fossil fuels, natural gas, methane, etc., shale gas extraction, because shale gas extraction, my dear friends, it uses a process called as hydraulic fracturing or hydraulic fracking. So hydraulic fracking is also somewhere it has high potential to cause an earthquake as such. Even heavy construction, Chinese Taipei, Taiwan earthquake is resulted due to what? Heavy construction. Even over extraction of groundwater, my dear friends. There is a place called as Lorca. 2011, Lorca is a place in Spain, my dear friends. 2011, they had one earthquake, and the reason cited for that earthquake is over extraction of groundwater. And of course, we have a reason for it. Spain belongs to Mediterranean type of climate. And Mediterranean region, generally, they are known for long and drought prone summers and wet winters. When water is not needed, there is more water. When water is needed, there is no water. So normally, the dependence on groundwater was more when it comes to Mediterranean region, including the regions like Spain. So that's the reason. Once over extraction of groundwater has also created what? Earthquake. Even my difference, nuclear weapon testing can also result in what? Earthquake. But one small difference I have just kept as a star mark here, because all other activities, what I have mentioned here, they'll be inducing some stress. The stress will get accumulated. Somewhere the rock will be reaching a threshold limit. The rock will break open. The energy will be released. But when I talk about nuclear weapon testing or any weapons of mass destruction when it is tested, there is no accumulation of energy. Directly, there is a release of energy. Right? So accumulation process is missing there. But whatever be the case, whenever, wherever any weapon of mass destruction is tested, this incident will be recorded as an earthquake, which somewhere, right, wherever I have this observatory, earthquake observatory, seismic observatory, or seismograms, that is somewhere which is located, that will be recorded as an earthquake. Even Pokhran, my dear friends, when India tested our capacity, nuclear capacity at Pokhran, this particular incident was recorded as an earthquake, right? Say, for example, the global map. Only we said no, it is not an earthquake. We went for our somewhere testing facility of nuclear weapons. Okay. Now, my dear friends, let me tell you, there are n number of lists. Net sources has given you more than 700 different ways how exactly an earthquake can be resulted, right? But what I have just given you is only 7. Now let me tell you, the logic is very simple. Wherever there is a large scale tampering of lithosphere is taking place by human activity, that can result in an earthquake. even quarrying. When I say large scale tampering of lithosphere, either it can be addition of this weight or removal of the weight. Am I right? Either you are adding more stress to it or somewhere, whatever it is there, if you're removing it, both can result in what? This earthquake. Possibility is always there. And my dear friend, some of the one, that's the reason I have just included this word called as etc. See, most of the time, this etc. should be taken very seriously because sometimes what happens, if I have just given a 7 list, somewhere, say, for example, students may assume that these are the only way that how exactly earthquakes can be resulted. No, not at all. Always keep the choice open-ended. I'll give you one bizarre incident, my dear friends. Right? So somewhere, just to tell you that, right, how exactly, what are the different ways that earthquake can be caused? See, 2018 World Cup. Very recently, we had this 2022 Football World Cup happened in Qatar, Doha. 2018, say for example, it happened in Russia. 2014, Germany was the defending champion. Germany was the champion, and 2018, my difference, the very first game was between the defending champion Germany and Mexico. Mexico was given the status they were considered underdogs. So, say for example, the very first game between Germany and Mexico, right? See, Germany, say for example, it is full of, say for example, almost the huge names and the great names, right? And Mexico, country-wise, it's very small, and of course, stature-wise also it is very small. That's what I said, the underdog status. Okay, somewhere it is kind of unequals. Now, what happened? Interestingly, the very first match, Mexico won the match. When Mexico won, all the Mexicans who were watching this match, somewhere it's a news. Even if you're searching in, say, for example, Google, you'll be taking this, say, for example, you'll be reading this news as such. So when all these Mexicans, my dear friends, watching this match got so excited, once, say, for example, Mexico won this game, out of excitement, they jumped into the air. And say, for example, when they landed together in the ground, right, that landing has caused one earthquake. That's the reason, sarcastically, we say even excitement can result in what? Earthquake. See, this is not an example, but I'm just telling you a bizarre incident. Right? Even say, for example, this incident was recorded as an earthquake in the seismograms. That's the reason somewhere I said, my dear friends, when we talk about man-made earthquakes, let's not confine that, okay, these are the only ways how exactly this, say, for example, earthquakes are somewhere induced by human activities as such. It is never-ending and never-ending. Okay, right. Now, after understanding some of the basic facts about this earthquake, my dear friends, also understanding that earthquake is not always a natural, it can also be man-made. I'll also talk about some of the very important scales that is measured or it is used for measuring an earthquake. See, there are two popular scales which is used to measure an earthquake. One I call them as what? Richter scale, and two I call them as what? Mercalli scale. Of course, India uses what type of a scale if you ask me? India uses Richter scale. And what is the basic difference? I'll tell you, my dear friends. This Richter scale is a magnitude scale, whereas Mercalli scale is an intensity scale. What is the magnitude and intensity? See, of course, most of the time, not always, most of the time, this magnitude and intensity, they are directly proportionate to each other. If magnitude is more, intensity will be more. Not always, again, I'm telling you. Okay. Now here, what is this magnitude? Magnitude is all about somewhere quantifying an earthquake, right? Somewhere measuring the size of an earthquake. Whereas intensity is all about assessing the damage that is caused by an earthquake. When I say size of an earthquake, my dear friends, what exactly is an earthquake? Earthquake is all about sudden release of energy. So somewhere you are calculating that energy that is released. And this released energy will be resulting in what? Somewhere shaking the earth's surface as shaking amplitude. You also measure the shaking amplitude. If you quantify, if you measure the shaking amplitude and the amount of energy that is released, that is what I call them as what? Magnitude. Magnitude is all about the quantitative scale. Richter scale is a magnitude scale. Whereas Mercalli scale assesses the damage. What is the damage? Somewhere I said, right? When I talk about damage, damage can be the assessment of loss of life and loss of property. Both. That's what sometimes we call them as what? Assessment of loss of men and material. Right? So when I talk about assessment of the damage, that same you call them as what? Intensity scale. Or of course, Mercalli scale is that intensity scale as such. And what are the other difference if you ask me, my dear friends? Richter scale is a log scale with base 10. And Mercalli scale is a 12-point scale. When we say 12-point scale, the scale rating ranges from Roman letter 1 to 12. What exactly is this Roman letters? Each and every letter or almost the number means that also I tell you. Okay. And when I talk about this Richter scale, my dear friends, Richter scale, actually speaking, Richter scale range starts from 1 and it may goes up to 10. But let me tell you, very practically speaking, this Richter scale is an open-ended scale. When I say open-ended, actually speaking, the upper limit is not there. But for all practical purpose, somewhere I'm just putting it as 10 because so far we have not recorded a double-digit earthquake. What we have recorded is somewhere around 9.7 or 9.6 approximately. This is the largest earthquake what we have recorded so far. That is 1960s earthquake of Chile. This Chilean earthquake of 1960 is the largest earthquake that what we have recorded so far. Right? Right, my dear friends. What we'll do, this log scale, we'll try to understand by example. And before that, I'll show you what exactly is this 12-point scale, my dear friends. See, Mercalli scale, as I already said, it has a Roman letter 1 to 12. Every number has a meaning. For example, 1 is instrument, 2 is weak, 3 is slight, 4 is moderate, 5 is rather strong, 6 is strong, very strong, destructive, violent, intense, extreme, and cataclysmic. Cataclysmic means catastrophic in nature. So one thing I understand, as the number increases, the intensity increases. For example, 1, it says not felt by many people unless and until there is a favorable condition. 2 is weak, felt only by few people at best, especially on the upper floor of the buildings. Okay, weak. So one thing I understand, as the number increases, the intensity increases. Read 12, my dear friends. Cataclysmic, catastrophic in nature. Total destruction. Everything is destroyed. Line of sight and level distorted. Objects thrown into the air. The ground moves in waves and ripples. Somewhere you imagine a Hollywood movie, right? Somewhere after a very huge bomb blast, you'll be finding that grounds will be moving like a sine wave. Am I right? Up and down, it will be moving. Right? The ground will be moving in waves and ripples. Large amount of rocks will move position. Landscape get altered or leveled by several meters. And in some cases, my dear friends, even the route of the rivers will be changing. It has the potential to change the course of the river itself. Right? That's what you call them as what? Cataclysmic or catastrophic in nature. Right? That is all about Mercalli scale. Now, my dear friends, Richter scale, my dear friends. Coming to this Richter scale. And here again, I have just given the frequency also. Both the Richter and Mercalli I have just given. Somewhere I told you, right, to this Richter scale, 2.0 and above, this is what we call them as what? Feelable earthquake. Okay. What can be felt, right? You call them as what? Feelable earthquakes. Only 2.0 and above, you call them as what? Feelable earthquake. When I said somewhere 1 million plus earthquakes are recorded every year, I'm just talking about 2.0 plus earthquakes, my dear friends. Right? So this data is given by US Geological Survey, right? Taken the data from that. Okay. Every year, at least 1 million feelable earthquakes. Only 2.0 plus earthquakes, we call them as what? Feelable earthquakes. Right? Right, my dear friends. Now, this image is more clearer than the previous one. Okay. Now, trying to understand the Richter scale. Somewhere I said Richter scale is a log scale, my dear friends. Log scale, and I told you that Richter scale is somewhere having a base called as base 10. What exactly is this Richter scale with a base 10? As I told you, right, somewhere we'll just by example we'll try to understand. See, for example, what Richter scale measures, I already said, shaking amplitude and energy released. Right? Shaking amplitude and energy released, my dear friends. See, for example, I'm taking 3 quakes, 3 earthquakes of 2.0, 3.0, and 4.0. On the face of it, if I'm comparing 2.0 versus 4.0, if it is an arithmetic scale, it appears that 4.0 is as twice larger than 2.0. But I understand it is not an arithmetic scale, it is a logarithmic scale. So given the fact, my dear friends, it is not as twice as big as 2.0. 4.0 is actually what? 100 times more. I'll tell you why. Because every number that increases in this Richter scale rating, the shaking amplitude increases 10 times. It means 3.0 will be having a shaking amplitude 10 times more than 2.0. 4.0 will be having a shaking amplitude 10 times more than 3.0. It means 4.0 will be having 100 times, 10 into 10. It is not 10 plus 10, 10 into 10. 100 times more shaking amplitude than what? 2.0. This is with respect to shaking amplitude, my dear friends. When it comes to energy released, if you ask me, My dear friends, 3.0, every number that increases, energy released increases by 31.6 times. So 4.0, 31.6 into 31.6, 4.0 releases 1000 times more energy than 2.0. That's the reason we say every number that increases in Richter scale rating, the size of this earthquake increases at least by 10 times. At least. Why I'm using at least by 10 times? Because energy released increases by 31.6 times. That's the reason I say at least 10 times. So, my dear friends, in that way, normally we say 6.0 itself is a very huge earthquake, large earthquake, right? See, for example, 6.0, you call them as what? Strong earthquake. 6.0, right? When talk about 6.0 itself, we call them as what? Strong earthquake. For example, if you ask me, this Bhuj earthquake is somewhere around 6.9. 6.9 in magnitude, my difference. Nearly 20,000 lives we have lost, right? So 7.0 is 10 times more bigger. 8.0 is 100 times more bigger. 9.0 is 1000 times more bigger, my dear friends, right? So somewhere this is what? Somewhere we try understanding by what? Examples as such, right? So somewhere each and every number that increases in Richter scale, the size of an earthquake increases at least how many times? 10 times. And my dear friends, this is about some of the very basic facts about the earthquake as such. So more such videos, often we'll be having it, and hope to see you in the future. So God bless. Thank you.